Integration by parts. This video will demonstrate integration by parts using two different methods, the formula and tabular method. This is the formula for integration by parts. Integral of u dv equals uv minus integral of v du. The next slide shows how the formula came about. The derivative of uv was taken. Each piece was integrated individually to obtain uv equals integral of u derivative v plus integral of derivative uv. This piece was subtracted over and rearranged. You use this if you see the product of two things and neither is the derivative of the other. These examples show two parts being multiplied. This one can't use it because it can be u substituted. In this problem, we're taking the integral of ln of x times x cubed. So u would be ln of x and du would be 1 over x. And v would be the integral of x cubed, which is 1/4 x to the 4th, and dv is x cubed. You then plug in the values into the formula and you get ln of x times 1/4 x to the 4th minus integral of 1/4 x to the 4th times 1 over x. Then you take the integral of that and then you solve and you get 1/4 x to the 4th ln of x minus 1/4 integral of x cubed dx. And then you integrate that. It should just be x to the 4th over 4 and you would multiply it by 4.
If you're too lazy to memorize the formula, you can always use the tabular method. In this problem, you're trying to take the integral of x cosine dx. Basically, you take the derivative of one part until it reaches 0, so x would go from 1 to 0. And then the other part, you take the antiderivative, so cosine goes sine x and then negative cosine x. Then you crisscross across this way, and then for the last piece, you go horizontally. Then you assign alternating positive and negative signs, and then you just multiply it through to get this answer. Don't forget plus c. It's very important.
What is u and dv? If there is ln of x, it is usually u. Otherwise, polynomial part is u. E to the x is easy to derive and integrate, so decide based on the other function. It's easier to derive than its u, and if it's easier to integrate than dv. Integrals should get simpler, not more complicated. The end.